Deyoung module solution. This is solution series on physics particles. If you have not been following the particles of other particle, please I encourage you to check the playlist, the physics particle playlist. You see other experiments like M6, M9, M10, and then I think a few other experiments, and then how to use solution material. And in case you've not gotten the solution material, please make sure you try and WhatsApp group where I explain in real time the practical solution manual by Deyoung MODULUS solution. No matter the university you are, solution material still remain the same, okay? And the experiment table of value might be different, but the experiment title and the aim still remain the same. All right, so this is the manual for now, the edition that they are using in University of Port Harcourt, which is my base. So if you come from any other university, make sure you follow up and then see check what your own holds, okay? So but the knowledge you are going to gain in this to be of help to you despite your university, okay, and anywhere you are watching this video from. All right, so my phone number again is 09157293443. So endeavor to join the WhatsApp group, and then let's interact one-on-one and see how we can help ourselves in this school business. All right, we've been on, like I said, on a solution on the solution to fizz particles, and I will always be there to ensure that I help students in this area. So please, if you've not before we start the video, if you've not subscribed to my YouTube channel, please do that right now. Please do that right now. God bless you. Do that right now. Okay, so just hit the subscription button and then turn on notification bell so that once I do, anytime I drop my video, you'll be seeing my video. So let's hit on to the cam scanner, my scan scanner, where I have all my work scanned. We'll be looking at M experiment, which is a compound pendulum, and I'll be showing you the there's so many different practicals on compound pendulum, but we'll look at the area where this manual focus, or the area the manual seeks to fit, and then the variable the manual wants to, oh sorry, the practical that is the aim of the experiment and what is expected of us, because there are so many variables that graph that can be plotted in the compound pendulum concern. All right, compound pendulum, I will quickly move down there. For this very manual, we have it as a M6. Now you can see up here, we have a experiment M4, which is a simple pendulum. Now in the simple pendulum, we use our normal pendulum bob, the thread, and then the retro stand, and then throw to get their work done. That is a simple pendulum. All right, so in compound pendulum, and let's see how compound pendulum look like. This is compound pendulum. All right, let me hit on compound pendulum. I know that simple pendulum is very, very familiar with us. We are very familiar with simple pendulum, but we're going to look at how compound pendulum is. And after this section, I prefer using the live broadcast or live session, so I'll be able to touch so many areas, okay, that is concerned. So this is how compound pendulum looks like. It's coming up. I want to show you how compound pendulum looks like before we look at the solution, and then there are a few things I want us to look at before we'll dive into the solution proper. Okay, so if you look at up there, the aim is to find acceleration due to gravity and radius of gyration. Okay, that is the aim, or what they call title there, but it's supposed to be the aim to determine acceleration due to gravity G, and of course radius of gyration K of a which is meter rule in this case. Now the apparatus here, they are the meter rule with holes. Of course, the meter rule, if you watch there, we have the holes. There are holes that have been bored on those meter rules, and those holes are for something. So take note of that. Then we also have, okay, of course, hole drills interval. Okay, we have at 5, 10, 15, 20, 25, 30, 35, 40, as the case may be. Then we also have the meter rule, which is what we have here. Then that is normal meter rule. Okay, we have the normal meter rule to enable us take some measurements of other things that we may also. Then we have the optical pin. The optical pin is what holds the drilled meter rule to the clamp or to the retort stand. Then we have a pin damp. Okay, damp is just to ensure that it holds the pin so that the thing does not wobble. Okay, then we also have the stand too, which is the retort stand that we all know, or any other stand. Sometimes can be mounted on the wall too. This is we are going to check on YouTube channel where it's mounted on the wall. All right, so any of the case is also very important. Then we have the stopwatch. Of course, you know what stopwatch is, to help you get the timing. And then we also have the knife edge. Of course, the knife edge is used to, first of all, you'll be asked to determine the center of gravity of the meter rule. Okay, then which we are going to also use to do some work there. All right, so moving on to the next page, we look at the method here. If you look at the method, just all those ones are the calculation background. You can go through that in your manual and the rest of them, but that is not my concern for now. Of course, if you look at the question 8 is giving us our normal pendulum, simple pendulum experiment. So from that equation 8, be able to have other equations, which is the compound pendulum experiment. So under the method, you look at, say, determine the center of gravity. Like I said before, determination of the center of gravity is number one at the of the meter rule by balancing it on the what, on the knife edge. Then now suspend the meter rule at a point nearest one end with the optical pin, then record the length. Okay, this LP. So like the meter rule has been drilled, and each of the lengths is going to be shown on the table of value anyway. So it's 5, 10, 15 up to 20 or 25, 30, 35 as the case may be. So you are going to see that, okay, that is the length, each of these lengths that is being drilled, that is the distance from that length to the tip of that very meter rule. Okay, counting from that length up to the tip, okay, is our LP. Then we also have what we call LG also, which is the length at the center of gravity, which is sometimes 50, 45, 49.5 as the case may be, depending on what your group is going to get. Then says the method 3 says set the meter rule into small oscillation, and then record the time in oscillation at least 3 times. Use the average value. Of course, you do it for 3 times. So you are going to put the meter rule at that hole, and then at that particular length, then you set it into oscillation 2 to 3 times at the particular oscillation that you are being given. So then I said 4, repeat the experiment when the bar is suspended from the 10, 15, 30, of course 40 cm mark, then tabulate your. So these are the readings that we're able to get from a particular student, okay, University of Port Harcourt. So these readings were very okay. So if we check on the left hand side, we have the LP. The LP, you see there are the lengths, the length interval, or the distance, the length of the drill, that is the hole. Those holes I showed you earlier that you have there, the hole that was drilled, the lengths, okay, of each of them, 5, 10, 15, like that. Now, if you notice something, though this is not showing very well, if you notice that after 5, okay, after 5, 10, 15, they skipped 20, 25. Please take note of this. They skipped 20, 25. All right, so take note of this, because I'm going to come back to this very point again and the effects of this very two number they skip in this experiment. All right, so and the one T2, T3 value was gotten, so you add and then divide by 3. That will give you average T. Then the period is the small t, that which is the average t divided by the number of oscillation. For example, we have 15.837. So number of oscillation here, I think it was 10. So if you divide that by 10, you are going to get 1.584. Okay, the same thing with the average on the second one, 15.983. The average there is 1.598. So please let me not forget this. In case your video is not that clear, I'm using like I said, I'm using a live video. Not just that, I'm using vertical display, and it's a mobile recording I'm doing. So what you do is that touch, if you have been following my videos, if you're able to understand what I'm trying to say here, touch the screen while you are on YouTube. Touch the screen of your video, and then ensure that you hit that you see the setting button that's on top of the video. Once you touch the screen, a setting button is going to pop up. Then we click on it to show you the different qualities you can choose from, so that you can have a very good bright this thing. Maybe you can choose 720 or high quality. or automatic or high quality, to be okay. Then don't forget to let the hit the screen and ensure that you see one square stuff down to show you to expand the video, so that the video is going to play full screen instead of playing it, so that your video quality, so that you can see everything that we have here. If not, you might not see it very clear, all right, depending on the kind of phone and the network you have. All right, if you've done that, thumbs up. So don't forget to subscribe to, like I said earlier. So that is it. So your period, like I said, divide the average time by the number of oscillation, which is 10, that was given in the question. Then to get your L is LG minus LP. Now they were supposed to record this guy was supposed to record the LG value. The LG value is your center of gravity value, you understand? So what you do is that you're going to subtract that from what we have here. So from what we have here, they have here LG minus LP, where your LG center of gravity. So most likely they got around 50.5, okay, because 50.5 minus 5 will give us 45.5. So if you use that 50.5 and subtract your LP, LP is the value on the left hand side, the first column you have, which is 5, 10, 15, 20, 25. This first column we have here is our LP. All right, so you do the center of gravity minus 5, center of gravity minus 15, center of gravity minus 20, until you get to what, 40. So that will give you the value on the L equals to LG minus LP column. Then to get your T square, of course, you are going to square your period, and your period are 1.584, 1.598, 1.546, and so on and so forth. So you square it. Of course, numbers you work with calculator must be in 3 decimal place. So that's why you have those numbers in 3 decimal place. Now there's a mistake I'm going to correct here, because I sent this material to some students, and then they were complaining about this. Now this L square is not times 2. No, L square means L times L. So but the student that have this, okay, did 45 times 5. That means you are supposed to square 45.5 and not 45.5 times 2. L square is not times 2. L square means L times L. So 45.5 times 45.5. Or you can use a calculator and then you get that done. All right. So that is how you work on your L square. Is that okay? That's how you work on your L square. Okay. That's how you work on your L square. All right. Okay. That's how you work on your L square. So yeah, the last one is LT square. So LT square is multiplying your L by your T square. So your L here is 45.5. Like, let me take the first row. 45.5 times your T square is 3.168. So try that with calculator and please confirm that value. But I guess that value is correct, because usually it ranges from that 130, 120, 1 something down, okay, 140, 150 down to around 20 something. So but here we have 42, no problem. That is being determined by your center of gravity value. Okay, so before we come to this very section of answering the question, we want to make a little video on the background of this. The solution is very straightforward. Solution is very straightforward. Okay, there's no much issue about the graph, about the work. So it's just the page we have here. So I'll quickly run down on the YouTube. So before we go there, I would like us to check this video on YouTube. This is what I do. I look at random videos, refer you to videos that will help you in a particular experiment, since I don't have the apparatus as required for now. But by God's grace, I'm setting up my own to see how I can also do this myself online. So for now, I want to recommend some videos to you. I'm giving credit to every person I'm working out here. So I'm going to check out compound pendulum. Okay, I was supposed to save some of them, but I didn't. Compound pendulum experiments. So let me do that quickly. Compound pendulum experiments, so that you see how it looks like before you go to, maybe if you are seeing this video before going to the lab, or after you must have gone to the lab. So there's something I want to say. Look at the guy, the first guy there, which is Chidon's Daniel. Chidon's Daniel is a Nigerian YouTuber, and I think, if I'm not mistaken, and he's really working so hard in his YouTube channel, and I've been following him for how many years now? Since 2000 and I think 2001 or 2020. I've been following him over 3-4 years now. So he has been doing very well. So mostly YX students come to this platform to get their information. So, and if you look at the table of value there, is quite different from the one we have, okay, but that doesn't stop the work. So we are just after to know what is there. Now look at the equation. Please take note of that equation. This equation, t equals to 2 pi equals to square root of, sorry, t equals to 2 pi times square root of k square plus h square over gh. That equation is what is obtainable in a manual, but there's a mistake there. They didn't complete that very statement in that manual, though in that manual they use L instead of h, but the equation there is very, very correct. Okay, so that is not, I just want to show you the setup, just how the experiment is. So you can see graph plotted in this very experiment, but the one we are going to look at is a very simple one. Back then we used to plot two graphs, one curve and then one normal one. So this is the compound pendulum. So I'm just checking YouTube videos, and that's, you can see drill holes on each of them. Drill holes. So let's show it again. These are the stopwatch and the rest of them. Okay, so those drill holes are what I want to see. So they will give you each of the value, what you are to put in there. Okay. So you can just slide your video to see what this man wants to do here. I think that is also a compound pendulum. Oh, that is a normal pendulum is doing. Let's see this one. So here they call it back pendulum. Sorry for that. I just want us to see. There were some videos I watched, but I forgot to save them. Even if I had saved them, I would have just seen the videos without having any chance. My this. All right. Compound pendulum. Yeah, it's all similar to the one we watched earlier. Okay, let's see this very one.
ये कंपाउंड पेंडुलम है, इसमें कुल 19 होल्स होते हैं। ये बीच वाला जो होल है ये कहलाता है सेंटर ऑफ ग्रेविटी। इससे 9 होल ऊपर की ओर और 9 होल नीचे की ओर होते हैं। प्रत्येक होल के बीच की दूरी जो होती है वो 5 सेंटीमीटर होती है। तो सेंटर ऑफ ग्रेविटी से दोनों छोर का जो लास्ट वाला
So you can see that we have a drill, hole drills from the top to the center of gravity, on both sides. Okay, so don't mind the language and our Indian brother. The guys they are very, very good. They are very, very good at this. So this just so the man is on the wall, so there's no issue with that. The man this one on the wall, so you can see that they have different drill. So and in the instruction given to us, the drill start from 5, 10, 15. That's the distance is 5, 10, 15. So you fix it the way it is, and then you oscillate it accordingly. So that is that. Then another thing again I want to show you here is you can come on and on to check different videos. You can come on and on to check different videos. You can also check another video here which I want to play. This is our Indian lady too. Physics experiment, but they call it bar pendulum in this case. Okay, that is a YouTube advert. Okay, that is how they make. That's how we make money in our YouTube. Okay, so that's it. Push it up until you get to that very center of gravity or that particular lane that is being given to you. So thumbs up to BMS College. Okay, that should be a school in this team. So she's also doing her best to explain that. All right. So that's by the way. So you can see the background study. They've given them everything. Like I said, a different graph that can be plotted on this very experiment. But for now, we will face the one we have here in a Nigerian university, and of course, what our manual says from the University of Port Harcourt, and of course, other universities that are using that manual I just showed us. Okay, so we'll go back to our solution. I'll go back to our solution on my CAM scanner. Let's see how we can provide answers to this very, how we can answer questions on this very physics practical experiment. So like I said, the solution material is just to guide you on how to do your own job. Okay, as far as is number one on campus. So I encourage you to share this with your friends. Please, if you've not subscribed, please make sure you hit the subscription button, and then share the video to your departmental friend, your classmates, your course rep, and every other person, your junior colleague, in case you are seeing this video as a year 2, year 3, year 4 student. Please share this video to your classmates. Okay, so let's quickly see that again. So in this section, I'll be explaining the answers, okay, what is expected of you to do after getting your table of value. Don't forget, after getting your table of value as a group, you are supposed to do your thing based on your own work. All right, so let's see. Challenge with this thing that is moving up and down here. Okay. Let's run that. Okay, that's an alarm. Okay, sorry for that. That was a call that came in. All right, so experiment MC acceleration due to gravity and radius of gyration. So the nature of the graph. Now, this is the nature of the graph that I have for now. Now, normally this graph is supposed to pass through the origin, but due to this thing we have there, due to the value that we skipped, okay, there's a way the graph is going to look like. Okay, the graph is going to have an intercept. It's going to have an intercept L on the L square axis, negative L square axis, because we were asked to find the intercept on the negative L square axis. If you go back to the question, we're asked to find the intercept on the negative L square axis. I'm trying to slide back there. I'm having some challenge. Okay, so you're supposed to get that on the L square axis. Okay, so that is a question number one. We are asked to plot the graph. Plot the graph of LT square against L square. So you can check the question, please, on your manual. I'm trying to slide that to give me that, but I'm having small little challenge here, and I have to be very careful so that the video doesn't just stop. Okay, I think I got that. Let me. Okay. Okay. Sorry for that. Okay, so question one says plot a graph of LT square against L square. So I don't really have the graph here, but the nature of the graph is what I just showed you earlier on. Then measure the slope of your graph. Then I measure the intercept on the L square axis. So because of those two values that were omitted here, we watch on the LPS side, we have 5, 10, 15. Instead of 20, 25, we have 30, 35, and 40. So the graph is going to jump, okay? It will jump and then it will cut on the negative L square instead of positive L square. We are going to the question that is being given to us, which is supposed to be under question 4. That equation helps you to know when a graph is supposed to pass through the origin, or when a graph is supposed to have intercepts, or the nature of the slope. Okay, there's much you know the equation. There's much you can know if you know the equation. So I will be able to show that when we come to answering question 4, where they say the period of the simple harmonic motion is given as this. They didn't complete that. Okay, so we'll see the right equation, okay, in this answer page. Then they say analyze this equation, making LT square a subject of the formula to depict the graph plotted. So we are going to transform the equation. Actually, the equation is supposed to be, if you watch anything that have to do with LT square and L square, it's supposed to be a curve. If you were watching very well, you saw that some things I did, so some videos I was trying to scroll through in the YouTube channel, you were seeing some graph. Okay, you were seeing a parabolic graph going this way. All right, if you watch very well, you can go back to the video to see the video. The graph was going this way, right there. So by the time you transform the equation and then you look at the graph plotted, you notice that you're going to get a linear graph. Okay, and there's another variable you are also going to plot, maybe L against T square against L, or L T square against L. You're automatically going to get a linear curve. All right, so that is that. Now we'll look at that very well. So I just wanted to look at the question, then we can always go back to it again whenever you're watching the video. You can always go back to watch the video again. So from your graph, obtain the value of G and K, which is the aim of the experiment. The aim is for us to find acceleration due to gravity and radius of gyration solid material, which is the meter rule in question. So calculate the error in G, and then what is the physical meaning of K, and then what are likely the sources of what, down to the solution panel. Okay, so we have this. Let me help to zoom this. Okay, this is just unwritten. Like I said, I'm coming up with a typed work very soon, and it will be readily available everywhere. Okay, so question 1, the nature of the graph. So this is what we have. Okay, I just give a nature. Of course, you must have 3 points to pass through your line of best fits, and then if you watch how the graph is going, it's going to cut on your L square, this thing L square axis. Okay, so I just give an idea about the scale. Now the graph will look somehow. So what you do is that you're going to shift some about 5 lines. Okay, 5. You're going to shift about 6 cm to the center of the graph, and then 6 cm to the from the bottom to the center, and 6 cm from maybe the left to the center. Or you can plot your graph in landscape. Okay, then you are going to get a very large. You're going to get large values. Your L square values could be around 2025, 1000 something, 2070 something, and the rest of them. So it's going to be a very big list. So the scale sometimes around 2 cm to 400. Okay, then or 2 cm to 300. That is on the L square axis. Then on the LT square axis, you can have a scale of 2 cm to 20 units, or 2 cm to 15 units, or 2 cm to 30 units, as the case may be, depending on how you want to maybe enlarge your work, or the best you feel you want to give it. Okay, so that is it. So if you have any issue there, please reach me on in our WhatsApp group for more explanation on that area. So I just 2 is our slope. So what I just did here, the formula you should be able to know, and the units for your slope, very very important. If you have issue of finding slope of graph, I will also make a video on that, but you can see, check on the YouTube channel on that. There are so many millions of videos on how to find slope of a graph. Or if you have any challenge, you can also come to my DM or in the WhatsApp group for us to discuss more about that. Okay, so and I'll give you a hint. I said ensure your slope ranges from 0.025 to 0.04. Let's assume 0.035 second square per cm. Okay, first of all, your slope unit is going to be second square per cm, because L will cancel 1 L down, that is cm will cancel 1 cm down, remaining second square per cm. That is the first you must know. That is the unit of their slope and must be added or included in your solution. So we come down to the hints I'm just giving you. So if your work is okay, if your experiment was properly done, okay, by your group, so you expect to have a slope from that ranges in that manner. Okay, I'm not saying that if you are going off from this range, you are totally wrong, but you might be wrong because there's a standard. Okay, because our aim is to find our G, and of course we know our G to be about approximately 9.8 or 10. Okay, so you are supposed to get something of that nature. But if you get 8, if you get 11, if you get 12, if you get 13, it's not that bad. But if you follow up this guide, it will help you to work within that range. Okay, if you have any challenge getting that value, that range, let me know in the comment section and also in the WhatsApp group. Okay, so the intercepts on the L2 square axis Okay, so well, I have to make this correction, please. I have to make this correction. The intercept was supposed to be on the L square axis and not LT square axis. Now, far back then when I was doing this, there was a particular graph that was plotted, and they were asked to find on this compound pendulum. They were asked to find intercept on the LT square axis. So this is what they also mean here, but because why I have to go through that very, I have that very I came up with that very idea, okay, or trying to relate it with that very work, was that the intercept on the L square axis is negative, and you need that intercept to solve for your k. As we are trying to get our k, you notice that intercept will be used, and this k formula has a square root. That's intercept over slope, square root of intercept over slope. That is k formula. So if you are doing that, you'll not be able to get your correct answer. Do you understand? You'll not be able to get a correct answer because you cannot find a square root of a negative number. So, but later on, I feel that okay, instead of us to do that, to use, to go outside that, why not we use what they say we should do? So what we do is that we are going to use the value, but we are going to ignore the negative value. Now, the essence, the reason why we have that negative intercept is because of what I told you. 20 and 25 was kept in that table of value. Peradventure or Arabian, we have that very value. Then there could be a period where maybe in the course of taking our slope, we just have to go down a bit. Instead of taking that 35 to 40, we can go down a bit to get to that 25, 20 or thereabout as our slope, something of that nature. So make sure we correct that. So the intercept is on the L square, not on the LT square. All right. So you can ignore that from the manual. Just understand what I just mentioned here. Okay. Now, is the complete or the correct table, sorry, the equation that I mentioned earlier. So in your book, it was not completely written. They just put t equals to 2. So this is a complete one. All right. That's under question 4 where we are asked to linearize the equation. So if you square both sides, this is what you're going to get. T square equals to 4 pi square into L square plus K square. Then going up here, we say cross multiply and open bracket. So we cross multiply our L down. Remember our L is down. So we are going to cross multiply to enable us get LT square equals to, we now open bracket, okay, LT square equals to 4 pi square L square over G plus 4 pi square K square over G, where slope is equal to 4 pi square over what? G, when you compare with the equation of a straight line. Now we're asked to make LT square the subject of the formula, and if you check the equation of a straight line, y equals to mx plus c. The y corresponds to the LT square, the x corresponds to the L square that you plotted on the L square on the x-axis, and y, you have 4 pi square over G corresponds to the slope or the gradient. Then finally, the intercept C corresponds to your 4 pi square K square all over G. So you can see everything there is in the equation here. All right, so question 5 says we should calculate our G and K. So you can go back to the question, or if you have your manual, you can go through it to follow up the work one after the other. All right, so using slope equals to G, our slope we assumed is 0.035. Okay, my data. All right, our slope we assume is 0.035. So that is how you do your own. So put your own value, then 4 pi square divided by your slope will give you about 127.95 centimeter per second square. All right, now to get the meter per second square divided by 100, that will give us 11.28 meter per second square. Now we've gotten our G. Now to get our intercept, we use our intercept. We are just equating the equation with our equation of a straight line. So our intercept would now be equal to 4 pi square K square all over G. Now let me say this again lest I forget. I was talking about why the intercept is positive. Okay. If you look at the equation of a straight line, which we have transformed, LT square equals to 4 pi square L square over G plus 4 pi square K square over G, you notice that if you compare this with the equation of a straight line, you're going to get y equals to mx plus c. Now check that intercept in this equation that has been transformed. We are getting plus 4 pi square K square over G and not minus. So we are not supposed to get a negative intercept. It's supposed to be a positive word intercept. So what we do is that when you are getting your value negative intercept on the L square axis, you are going to ignore that negative sign and then you use the value the way it is. Okay. So our intercept there for now is 30. So you can put your own will be around that 3 to 400 and something, because it's going to cut on the L square axis. So about 3, 4, 5, 6, 700, 750, 800, as the case may be, depending. You get that. So you put the value, divide by your slope, and then find the square root of that. So convert to meter if need be. All right. So the error in G. So the error in G is simply we'll look at how do I call it? We'll look at difference between, remember, G is a standard value, so don't just use the normal formula that you know, 4W over NR, error in graph, and the rest of them. No. So G is standard. So the error is like we want to do the deviation from the original value of G, which is like a standard error in G. Okay, very simple way you can get it is for us to subtract. Okay, so our measured value, that is a theoretical value minus measured value, or experimental, how do I call it? Theoretical value, that is the standard value minus measured value, experimental value. Or you can do it the right way around, subtract it, and this is what you are getting. So you'll be getting about plus or minus 1.48 after doing that very subtraction. Okay, so then the error now will now be 9.8 plus or minus 1.48 meter per second square. Normally we put it in bracket and then we say limit of estimated standard error. Okay, finally we now have, they say, what does the K represent physically? So the K is the radius of gyration of the meter from the center of gravity. Okay, so it explains how the masses are distributed in the world, the object. Okay, let me just give you a clue. Okay, those in University of Port Harcourt, you are going to get physics 101, which is mechanism and properties of matter. Now, if you have your an object, talk about center of gravity. Center of gravity, it is that point in that object where the total weights of that very object appear to be concentrated. So it means that all the weights of that object, when it's under the influence of gravity, tends towards a particular section in that very object. All right. So each of them have distance from where they are to the center of gravity, or to the center of mass. Sometimes center of mass, center of gravity, just a slight difference there due to gravity. Okay, so now the distance from each of the masses, each of the particles that constitutes that very solid object, okay, that rigid body, the distance from each of the particles that constitute that rigid body or that solid object, okay, is what we call radius of gyration of that very object. Okay, so that's what it actually means, and that's the essence of the experiment. Okay, so that's that. So finally, we look at question A, which is sources of error. So please, most students over the years mistaken sources of error with precautions. Okay, sources of error is not precaution. Sources of errors are just those things. Okay, let's assume the value of G is 9.8. We are supposed to get, or 9 or 10 or something we are supposed to get, but we are getting 11 point something. We are getting 12, or you are getting 13. So what do you think is the reason? To you as a person, okay, as an experimentalist, what do you think is the reason why you did not get that exact value? Let's say you are getting 7 or 6.5 meter per second square, all right, like the G in moon also. And then, so what are the areas that brings about this error? So number one is error from the stopwatch. So the error could be maybe wrong timing from your stopwatch. Maybe you did not time the time you release, you oscillate that very bar pendulum, or that very bar, that ruler, you did not start your timing, and then, or you start very late, or the case may be. So wrong timing also. So you can also have a zero error of the can do that. So if the stopwatch has a zero error, and then you didn't notice it on time, and you start taking reading from a particular point, then it's going to be a problem too to you. That could be a cause too. And we also have error from the meter rule. So that could be a parallax error, which is under question option D. Question D, and that's answer D, error due to parallax. So error due to parallax, and then meter rule too. If the meter rule is faulty, you also have a problem too. Just like the stopwatch, if it's faulty, you have a problem too. So you can also talk about systematic error if need be. Yeah, you can talk about systematic error in this case. So error from the meter rule. Okay, if the meter rule is broken, there's a problem with the zero, the counting and everything. You could also have issue with that. So error from drought. So drought is all the air resistance, from wind, we call it breeze, from the fan, from window opening, and the rest of them. That could also be a reason why you didn't get the actual value of G as expected. Then finally, we also have personal error. So it could be your own judgment. Okay, maybe you judge wrongly. Okay, erratic error. Maybe you just assume value. You just do the hurry. You want to meet up something, and then you just anyhow you like, you just do it, go your way. That could also be a problem. Then the last one we have is random error. Now, random errors are errors that you cannot just predict them. Okay, you cannot just actually say this is the exact cause of it, and that is the reason why we take average value. Yeah, in your defense, I'll ask you this question: why do we take average value of our timing? Why do we take T1, T2, T3, T4, T5, and the rest of them like M4 experiment? Okay, majority of the experiment you see T1, T2, T1, T2, T1, T3, T3, T4, and like that. So the essence is to correct for what random error, because each time you do T1, T2, T3, you'll be getting different value, because the error or the cause of that very error is random. It cannot be predicted. Okay, like that, just the environment and the rest of them. So any other one please, you can add up. Don't forget, this is the Deyoung Module Solution, and I'm here to help students in University of Port Harcourt and every other university that are using this manual or are doing something relating to compound pendulum. Okay, based on the questions we have here, I'm answering on the scope, based on the scope of the questions we have. So if you have any other question on the compound pendulum and you feel that it is somehow different from your own, from what we did, so please just share it. Check my WhatsApp group. WhatsApp number 09157293443. Join my WhatsApp group, and also of course, share the video to your friends, to your loved ones, to everyone that knew that. And if you've not subscribed, please subscribe to my YouTube channel. Once again, if there's any corrections that you feel, maybe statements or things that I've done here, and you feel it's not okay, please, you have room for it to positively criticize, and then drop your comment in the comment section. I'm always there to learn. Of course, before I brought added solution material, I've done my review sometimes, okay, some years back, okay, over 14 to 15 years now. It's a long story anyway. So, but that doesn't mean that it's not subject to correction or to criticism. It's allowed, okay, do it constructive, positively, and I will always welcome that on my DM, of course, on the comment section. God bless you, and have a wonderful day. So, other video session will be coming up. I will see have more 4 or 5 videos, and don't forget, second semester you also get a lot. In before second semester, I'll be getting all the videos ready. Okay, this is March 14th, 2024. Okay, I started the YouTube channel last year fully. Last year, I think July or so. I'll be June, July last year. I'll be February, like February last year, but it came in full flesh June, July. So we'll always do that together. All right, thank you, and